Hi, everybody. You've already learned how to represent sentences in Venn diagrams. Now what I want to do is see if you can figure out how to assess validity with Venn diagrams. So here I've given you an argument just with Venn diagrams. This is the premise, and this thing down here is the conclusion. So this is our argument line. That just means therefore or hence, like it's meant all along. You tell me, is this argument valid or not? That's what I want you to try to figure out. So pause your videos now and see if you can answer this question. Okay. We're going to talk about the answer now. In order to answer this, you have to remember what our convention was. So we said that shaded means true in these Venn diagrams. So this is our sentence. This is our disjunction, P or Q. So this was shaded in regions 1, 2, and 3. So this is the sentence P or Q, or A or B. What is a sentence like this? Well, this is actually a tautology. This is shaded in every region. So this is true on every single row of the truth function. That's what this sentence is. But in order to assess for validity, you actually don't need to understand which sentences these are, because just think about what the rule of validity says. Validity says if the premises are true, then the conclusion must be true. Well, think about what that means in terms of our code. If the premise is shaded, anywhere where the premise is shaded, the conclusion also better be shaded there. And if that's the case, if it meets this test, then the argument's going to be valid. It's a valid transformation of shapes, of pictures. So this one is valid because here's our test. Let's look for wherever the premise is true. It's true here, and it's true here and here. Is the conclusion shaded in all of those regions? Yes, it is. So wherever this is shaded, this is also shaded. So it's great, it's valid. Now you might be wondering, but wait a minute, see where this is not shaded and this is shaded? Isn't that a problem? No, where the premises are false is irrelevant to validity. Validity just cares about when the premises are true. Is the conclusion also true there? Another way you might have figured this out is, remember tautologies, logical truths follow from anything. So this is one of actually our weird cases of validity. This is valid because, of course, a diagram shaded everywhere can never have a counterexample. So that's always going to be valid. Okay, now if you didn't get that one, let's try again. Here's another one to practice on. So here's argument number 2. Pause your videos and decide if this argument is valid or not. Okay, that was your chance to figure it out. This one is invalid. This is not valid, and here's why. If the premise is true, is the conclusion always true there? And the answer is no. Look at this region number 2, where P is true and Q is false. Look, it's not shaded here. This is the counterexample. This is the problem here. So it's no problem if this is shaded and this is not, or excuse me, if this is blank and this is shaded. What's the problem is if this is shaded and this is blank. That's the issue. That's the invalidity. So this argument is not valid because of this region right here shaded and it's blank there. So this one is invalid. Okay, so the point of this video is, just like we can represent sentences in Venn diagrams, if you think about how the concept of validity works, you can also see how validity is represented in Venn diagrams too. Of course, the same goes for logical equivalence. What would a logical equivalence be in Venn diagrams? It would just be the exact same diagram. That's really easy to tell when two sentences are equivalent. They're just the exact same picture. So that's how we can evaluate validity in terms of images. Okay, thanks.